Because electron has its own charge, just depending on how many electrons, you can calculate the total charge. This is simple, but I can add additional questions to this. I can ask this charge move along a wire for 15 seconds. What would be the current created by those electrons? So you shouldn't forget the main logic, and then use that information wisely. Or again, since you know the definition of the current, you should be able to calculate. Given that Q is a function of time, you should be able to take the derivative. If I ask you what would be the current at t equals 15 seconds, again, you should be able to answer. These are not complicated problems. I'm not planning to ask any integration, so don't worry about it. So we have talked about this. This is, in general, might be representing anything in our electrical circuit. It might be a resistor, potential source, doesn't matter. The idea is, if they are the same thing, and if we are trying to calculate what is the potential difference between the point A and B, this one and that one are exactly equal to the same thing, because this is, A is the plus sign, so compare the potential difference B and A if it is 9 volts, and in this case, if this is plus, this is minus, the corresponding potential difference is going to be minus 9 volts. So you should realize that just changing the polarity only change the sign in front of that number. So again, you have to know what is the definition of the power, how we calculate it. So when I ask power, don't tell me that power is potential multiplied by the current. That's a way of calculating power. That's not the definition of the power. In an electrical system, yes, that's how we calculate power, but that's not the definition of the power. Just keep in mind. And remember, we have talked about the active and passive elements in our electrical circuit. So when you are going to calculate negative power, when you are going to calculate positive power, keep in mind. So these are simple analyses which are just based on the current and the potential. You are supposed to calculate what is the power. And remember, again, with the perspective of electrical engineers, because this book is written for basically electrical engineers. And what they do, overall, the power in a system should be zero, because some elements providing power, some elements are just consuming it. So overall, the element power is negative, consuming is positive. So when we add all of them together, it would be zero. Actually, in the midterm last year, I asked a question regarding that, which I will show you anyway. So you have to remember the logic that we use. Application test. I did not solve, I think, the question like this. But let's say if this is the Q, how the Q changes with respect to time. And if I ask you, sketch current versus time graph, what you're supposed to do. So I give you Q versus T, but I'm asking you this. What are you supposed to do? What is current? dq over dt. If you have a function and you can take a derivative in that function, what derivative gives you actually? So if I take derivative between 0 and 2, what will be the answer? So in this QT graph, if I take derivative for the first 2 seconds, what would you get? Slope. So slope, which is dq over dt basically, would give you the current. So if you have Q versus T graph, you can extract I versus T graph from there. In this case, it was, let's say this. 1, 2, 4, So for the first 2 second periods, our slope is constant and it's just 50 divided by 2, 25. So which means our current for the first 2 seconds would be 25 amp. What about the next 2 seconds? This time it's minus. This one? It's actually the same line, right? It continues, so the slope doesn't change. So up to 6 seconds, actually it's the same line, so the slope is same. For the last 2 seconds, this time it's going to be positive. Again, it's going to be 25, so that would be 25 amp. Yes, I never solved this kind of question, but this is not difficult. If you know this, you should be able to extract this graph from the QT. That's usually what I say to students. Do not assume that all of the questions that you're going to see exam are going to be similar to the one that I solve in the classes. They will not. Because I would like to check, do you really understand what this means or not? It's not just solve problems numerically and get the right answer. That's not my purpose. Any question regarding this? So chapter 2, we start to discuss the basics now, where in our circuit we have potential source, most of the time battery, and resistors. We have discussed what this open circuit means, right? Remember, we said that open circuit means when you have air, it's almost impossible to create current in air, which means air is resisting against current. That's why when you have an open circuit, this part can be represented by a resistance which has a value of infinity. So it's almost impossible to create current here. These are simple applications. And again, in my calculation, I am not going to use conductance. I will be using in the resistor. In the book, I also mentioned the conductance, but in our calculations, I will be always using the resistance. So we have talked about the current sources, because I think up to this point you didn't really talk about the current sources, because most of the time in physics we talk about the power sources in terms of potential. But in a realistic case, in an actual electrical circuit, it's possible to provide just the current, and then you can use that current to create or provide energy in your circuit. So this is very simple, but given the current in the system, the problem might ask you how much potential is delivered to this resistance, how much energy dissipated for a given time, or what is the power of this resistor. So simple, basic information, but sometimes although it is simple, students may have problems. So we define what node, branch, and loops are, because we use those terminology in our calculations. So you know what's the, so again, very simple question. If I give you a circuit, and if I ask you how many nodes you have, how many loops you have, how many mesh you have, do you have any super nodes, do you have any super mesh? When I ask them, you should be able to answer. Again, that's not about the solving problem, that's about did you understand all the concepts that we have discussed or not. We have discussed the Kirchhoff laws, which actually all the time we are using this two law anyway. First one was Kirchhoff current law, what it was saying, if we have a node and if there are different currents that are coming into that node or leaving that node, Kirchhoff current law states, if this is node A, if I calculate all of the currents that entering into the net, not entering, that are at the node A, it should be 0. So again, the only way to get the 0 is some of the values should be positive, some of the values should be negative, and our, let's say, the convenient way of doing it, if a current is entering to the node, it's accepted as positive. If it is leaving the node, it is accepted as negative. So that's why when we put this equation, we have I1, so I1 is entering, so that's why we are adding that. I2 is entering, so that's why we are adding. I2 is leaving, so we are subtracting it. It's 0. That's why I3 is I1 plus I2. Again, when you look at this picture, you realize that it's not a complicated problem. But if there are going to be more than 3 currents, if the directions are going to be all around distributed, make sure that you are writing that KCL correctly. And KVL is, this time, instead of focusing on the node, we are focusing on the loops. What the problem was saying, based on KVL, if I have this, let's say, loop, A, B, C, D. KVL tells us that if I start from some point and move around this loop and writing potential across each circuit element that I pass, when I came to the point A, their summation should be 0. And again, logically it should make sense because we are calculating potential difference. When you start at point A, and then you came back to the point A, it's exactly the same point. So potential difference should be 0 on the same point. That's the logic behind this. So here what you calculate, VBA. So first you pass through this circuit element, you are writing what is the potential difference between B and A. Then you are writing what is the potential difference between C and B, plus D and C, plus A and D. So when you add all of them, it's going to be 0. Sometimes some of them are going to be positive, some of them are going to be negative. That's why you have to be careful about passive and active convention. And remember, there's a simple rule. Again, this is not how we teach it in Physics 102, but in the perspective of electrical engineers. Since resistance are passive elements, we would like to always get positive power for this. So most of the time, what we accept, that's the distribution. So current from positive side to negative side, because that's actually what is expected. Current should flow from high side to the low side. So these are our circuit elements. In the KVL, let's say this is the loop that we have. We have 2 battery sources, we have 3 resistors connected in our system. So sometimes in the problems, positive and negative signs are given, but if it is not given, again, what we expected most of the time, that the current should enter to the resistance from the positive side. Right? And here, you don't have to put any sign because the sign, or if it is shown like that, or like that, it gives you actually how the potential changes. But KVL, application of KVL in the system is, so again, we are starting from one side and trying to write potential across each element. First one, we are entering from the positive side. So that's why first one is I times R1. Actually, that's how your potential is not increasing, right? That's why in Physics 102 we are teaching the other way around, because what happens in an actual life? Current is flowing from high potential to the low potential. So actually if we move from this side to here, your potential is not increasing, it is decreasing. But at the end, the way that we write this equation gives you exactly the same equation. This is going to be just some equation multiplied by the negative sign, which is at the end is correct. But by just looking at the positive sign and negative sign, this is much easier to write because you don't have to worry about to figure out if this potential is increasing or decreasing. Just accept that when you enter from the positive sign, it's going to be again I times R2. This time you are entering from the negative sign, so it's going to be minus delta V1. When you enter from this side, since it's positive, it's going to be I times R3. This one, you're entering from the positive side, so this is going to be delta V2, which is, we came to the same point, so it should be 0. In this equation, what we have got, delta V1 minus delta V2 divided by R1 plus R2 plus R3 should be equal to I. In physics 102, again, how I teach it, by the way, this is not wrong, if I didn't make a mistake, but in physics 102, how we teach it, current should flow from high potential to low potential. So when I move from here to here, I know that my potential should decrease. That's why actually, I write minus I times R1 when I move across this one. Again, when I move across this, still this is the direction of the current. I am moving parallel to the current, which means my potential is decreasing. This time, if you think about it, when I move from here to here, my potential, will it increase or decrease? It will increase, right? Because polarity here is positive. It means this side, I am actually increasing my potential. So again, this is decreasing. And the last one, this is positive sign, this is negative sign, which means actually I am decreasing my potential. As you see, it's just the same equation multiplied by the negative sign. So, doesn't matter if you use the logic or just the conventional way of electrical engineers, both of them should work. To understand this is going to be important because if I ask you specifically what would be the potential difference between 2 points, you should be able to correctly figure out that one. Because this might not be really helping you to calculate the exact potential difference. You can get positive sign instead of negative sign if you are not careful. And actually in the exam I will show there was a question which I asked what was the potential difference between 2 points. Okay, any question about KCL or KVL? You know that we have also dependent potential source or dependent current source. You remember that they are connected with some values in your circuit. Please don't forget that part. Let's see if anything here. So, current division and voltage division. Again, voltage division and current division, they are just the application of the Ohm's law, nothing else. If you know what parallel connection and what series connection means, you can calculate them. But sometimes really using the current division rule or potential division rule might be much more simpler. Otherwise, you can use the Ohm's law and solve any problems anyway. So what voltage division rules tell us, when we apply voltage division, do you remember? What is the condition that you can apply voltage division rule? You need a potential source and resistors have to be connected in series against our potential source. So if the problem asks you what V3 is, again, you can use Ohm's law because you know how to calculate current here. Once you have the current, you know that potential across the resistor can be calculated as I times R. That's okay. But if you don't need to calculate current, that's when you're supposed to use voltage division rule. If you don't need the current, independent of that calculation, you can use voltage division, because what voltage division tells you, these are all having the same current, right? Which means their potential is really depending on the resistors they have. If they have a larger resistance, they will have a larger potential. Depending on their ratio, they share this potential. So voltage division is just really based on that. I have my potential source, which is shared by all of them, but depending on the one that I am interested, because I am trying to calculate what is the potential across this resistor, I can just use voltage division. Again, calculate the current and then calculate the potential is not an issue. You can do that. This is just sometimes will be much easier to calculate. And in case of current division, we don't want to have a potential source. When we have a current, actually it's not really true. I might also have this one still. So it doesn't have to be really current source. I can still use this one. Let's make this a little bit more. This might be our configuration. I might be asking you what is the current flowing through R1 and R2. Let's call it I up. Let's call this one I down. Or I might be asking you what is the potential across R2. So here you have options. Depending on what you would like to do, you have a few options. Either you can understand, let's say, parallel and current division, not parallel. How parallel connection, what kind of information parallel connection gives you, what kind of information current series connection gives you, or by getting this, I know that it is just current flowing through here and R2. And to get that value, I can just use the current division rule. But be careful with the current division rule, especially if it is not just not this one. Still, the current division rule works with the same way, but just when the configuration change, do not just make an assumption, really understand how we are supposed to calculate it. So how I can calculate this current by using current division rule?
Are you good for the parallel circuits? Always open.
Ama ohm yasasını kullanmak istemiyorum şimdi ben. Current division'ı kullanmak istiyorum. Nasıl kullanırım diyorum. Ohm yasasıyla çözebilirsin. Yani ona karşı bir şey yok. Ben diyorum ki bunu current division'la çözmek istiyorum. Nasıl çözerim?
I çarpı R1 1 bölü R1 artı R2.
That's the issue that you have to remember. When I focus on this R2, I cannot ignore R1 because R1 plus R2 gives me the value of the current. So when you use the current division rule, you cannot just focus on R2. Remember, this current is flowing through R1 plus R2. So when I calculate the current division rule, this one should be, yes, I am sharing my IS. And again, logic is based on Ohm's law. These are parallel to each other. This and this one should have exactly the same potential. That's the logic behind it. And then we are writing those Ohm's law a few times, playing with it, and we are obtaining the final answer. But if you, let's say, depending on how many question writing you solve, then eventually you start to see how you can just in a short way calculate those. So what we say, yes, that's the current we are trying to share. Remember, this is the current with the parallel connection, so it's not linearly proportional with the resistance, it's inversely proportional with the resistance. Because if your resistance is higher, current is gonna be smaller. So this is 1 over R1 plus R2, because the current is not just flowing through the R2. They are flowing through R1 plus R2. In here, this is gonna be 1 over R equivalent of this system, right? Which is 1 over R1 plus R2 plus 1 over R3 plus R4. So we have discussed delta and wire connection. You know that some of the time, if you don't have those analysis methods that we have discussed in the later chapters, like mesh current analysis or node voltage methods, sometimes KVL or KCL will not be enough to solve the problems. So that's why sometimes you can do delta to Y to delta conversion. I'm not going to repeat everything from scratch, just go back and review that part, please. In some problems, it might be necessary. Let's see. Now came to the methods of analysis. So, node voltage methods. Which Kirchhoff rule we apply in the node voltage methods? KCL. Remember, the idea is, again, I'm just going to draw some random circuits. How many nodes we have in this circuit? Node 1, node 2, 3, 4, and 5. Remember what node voltage method was telling us? We are going to choose a reference node so that everything else can be written with respect to that. There are different choices. You can choose this one as the reference one too, but it wouldn't be useful. So that's why you have to figure out what would be the best one. And if one of them is combining many nodes anyway, it would be more useful. So I will accept that this is my reference node, which is, this is going to be the part that I will be ground my system. So this is going to be the point that I will accept my potential is going to be 0 at this node. So everything else will be written based on this value, like this one. Do I know the potential here or not?
I know.
Yes.
I know, right? Because I know that this is 0, and this is my battery source. What would be the value of potential here?
Minus
V2.
Good, minus V2, right? It's not plus, be careful with the sign. So this is minus V2. Do I know the value here?
Yes.
Again, same thing, this is 0. Now I have a potential source connected, and since this is a positive sign, this is V3. Do I know the potential here?
No.
So this is, let's call Vx. Do I know the potential here?
No.
Vy. So these are independent potentials because they are not connected to other plates. Then we have the nodes. So we are going to write KCL in the nodes that we don't have information. Let's put some currents. I1, I2, I3. Do I need another current?
Yes.
Because I1 is basically this current, right? I2 is this current, so I don't need another current. So if I write KCL at this node, I1 is coming, I2 and I3 are leaving. So KCL at V3, tell me that plus I1 minus I2 minus I3 should be equal to 0. I1 equals to I2 plus I3. Can I really use node voltage method in this equation? I will start right and then we will figure out. Remember what node voltage method was saying. How I am going to get the value of I1, right? That's the node voltage means. I know that I1 is a current flowing from this potential difference to that one. So this is a higher potential because we decided that's the direction of the current. It should flow from high potential to low potential. Ohm's law, potential difference divided by R should be current. So the value of this I1 is going to be Vx minus V3 divided by R2. By the way, except Vx and Vy and the currents, everything is given. So I know the resistance value, I know the potential values for those sources. So, equals I2. I can still write the value of the I2, right? Which is, this is V, or, it's not V3 minus, there's V1 here. So what is the potential here?
Minus V1.
So it's V3 minus V1, right? Because I have V3 here, I added this battery source, and since this is the negative side, the potential exactly at this point, V3 minus V1. Clear? Now I can look at what this current is, because this current is flowing from this potential to that potential. So I2 will be V3 minus V1 minus V2 divided by R1. Now I am supposed to write I3. What is I3?
V3 minus 0.
Over what?
Just
This is supernode, remember? Because we don't know how we can calculate this curve because no resistance is given. So between the two nodes, if I have only potential source, this is called supernode. So that's why I cannot complete this equation because I don't know how to write I3. By the way, this might not be the perfect circuit because I randomly drew it. There was no logic behind it. I just put those things. But what was the idea about the supernode? If we have supernode, what we were doing?
Ortasını yoksa soldan sağa.
This is my node, right? Anything enter to the node should also leave the node. So instead of focusing that node, this time I'm going to look at what enters here and what is leaving here. So I1 is entering, I1 is leaving also, right? Because this is also the same thing. So that's enter leaves. This question is really not useful because it's not going to be solved.
I3 is 0.
So it's not going to be solved. That's why I said it's the random question, so it was not realistic. But remember the problem with the supernode. When you have a supernode, you cannot write this equation because you don't know how to write the value of this current since it's just flowing between two potentials without any resistance. But that doesn't mean that there is no current there. There is current. Just we don't know the tool to calculate that one. That's why you have to use the supernode, which means adding all of the currents entering or leaving to the supernode should be 0. Again, this is not a perfect example. I really didn't think about it. What about the mesh current analysis? Should be example. let's put this one and then try to understand how we can use mesh current analysis. So, using mesh analysis, find I0. And I'm not going to follow exactly the same mesh current so that we can write different equations but still get the same answer, because it doesn't matter which mesh current we choose, the result should be same. So idea here, we have 3 meshes, and for meshes we have loops, right? We know exactly how to write KVL for each mesh. But here, remember, we are not using the actual currents. We are just defining some currents for each mesh. I'm saying that this is my first mesh current. This is my second mesh current. This is my third mesh current. I just choose the other way around, so. But the idea is same. For each loop, for each mesh, I'm going to write KVL, and then we will obtain 3 equations for 3 unknowns that we have. Just one thing that we have is I0. I think this I0 and that one is the same thing. It's written small and upper, but we don't have any other I0, right? This should be same. It's written uppercase and lowercase, but I think they are the same thing because we don't have another I0. So remember, this value of the potential source, this is not a current. Because of the symbol, it's plus and negative sign, it's not an arrow. So this is the potential source, which is depending value of the current over here. That's the thing that you should not forget. So I am going to write KVL first for the top mesh. And I would like to start from here. Since that's the direction of the mesh current, I will also go in the same direction. Because I would like to write positive potential when I move across the resistance. So, when I move across this, what should I write? What will be the potential? Plus 6 I1, right? When I move across this one,
Plus 4 times.
that's the thing that you have to be careful, right? There are 2 currents flowing across 4 ohm resistor, and remember we would like to write positive potential difference. So that's why the current, the larger current, should be parallel to the direction of our motion. So I1 is moving in this direction, I2 is moving in opposite direction. So that's why when I write potential across 4 ohm, I'm going to write I1 minus I2.
Hocam, peki 6 ohmlukta I0'yu da katmam gerekmez miydi?
Ondan sonra geliyor. I0 yok şu anda. Ben de dedim gerçek akımları kullanmıyorum dedim.
Tamam.
I0'nun değerini yazarım sonra ne olduğunu. Ama bu denklemlerde öncelikle mesh current kullanıyoruz. And we have came to the last one. 8. So again, I would like to have a positive one. I1 is moving in this direction, I3 is moving in that direction, and since I am going in that direction, it's going to be I1 minus I3 equals to 0. That's my first loop. Now, left bottom mesh. So again, I am starting from here. I am moving upward across 2 ohm. So it's going to be plus anyway, because that's how we write for the resistors.
I2 minus I3.
I2 is moving in upward direction, I3 is moving downward direction, so it's going to be I2 minus I3. Now when I move across 4 ohm, This time it's gonna be minus I2 minus I1, because I am moving in this direction. That's parallel to the I2. I1 is moving against me, so that's why this is negative, but this one is plus. And I am entering from the positive side of my potential. So that's the second mesh.
Eksi 16 olmasın. Doğru yanlış.
Böyle geliyor değil mi? Last one, I start from here. Entering from the positive side, 10, I0. Remember, there is a value of the current, but this is still a potential source. Plus 8, I3 minus I1. And the last one is 2, it's going to be I3 minus I2 equals to 0. I need one more equation.
I1 equals minus I0.
That's the thing that you have to see. Now we came to that point. This is the mesh current. This is the only current flowing through 6 ohm, right? And this is the only current which is flowing through 6 ohm. So I0 should be equal to minus I1, which means we have 4 unknowns, 4 equations. I1, I2, I3, and I0 are the unknowns. We have 4 equations. You can solve this one and then get the answer. And it can take time, but you can solve those problems. What you're going to do, just get rid of each unknown one by one. So in the first equation, instead of I1, maybe you're going to use the value of I1 from here, which will depend on I2 and I3. Then by using this one, again, you have to get rid of I1 too, but combine them, you will have a single unknown. It may take a while, but you can find it.
Bir şey sorabilir miyim? Sınavda bunu yazıp en son matris haline getirip bıraksak olur mu?
Evet, muhtemelen öyle sorarım. Çünkü herkesin bu denklemleri çözecek hesap bilgisi olmayabilir. O yüzden 4 bilimli, yani 4 denklemli problem çözmenizi beklemeyeceğim. Any question? So I will have a quiz, which is not related with what we have discussed so far, but this is something that you have learned last week, so that's why you can solve it.